Okay, let's get started. Good afternoon, everybody. My name is Kumar Sankaran, and I'm the Vice President of Software and Platform Engineering at Ventana Microsystems. In this demo today, we'll talk about SmartNIC and OvS-DPDK as an application to optimize the performance of a SmartNIC. So we'll start with what we'll be showing is a switching application with OvS-DPDK. So I'll talk through some of the terms that we are talking about here, like what is OVS, what is DPDK, what are the applications, and how they all tie together. And we'll talk about the software stack that we are showing here. And also, finally, we'll do a video, an actual video that is done by one of my colleagues that will show this application running during the actual runtime. So what is OVS? OVS stands for Open Virtual Switch. It's a software implementation of a virtual multi-layer network switch. And it can either be run as a virtual switch on a hypervisor, or it can be run on bare metal, which is on the hardware platform itself. So it's fully open source, released under the Apache 2.0 license, and it's fully integrated within the Linux kernel. And it has support for multiple protocols like NetFlow, SPAN, 802.1, AG, and more. These are just some of the list here. DPDK, what is DPDK? Data Path Development Kit, and that's a framework to accelerate network performance or network processing workloads. It's again fully open source under the BSD license, and provides a set of data plane libraries and NIC polling mode drivers to offload TCP/IP stack processing from the kernel to user space. So effectively, you can examine the packet, process each packet in user space in Linux versus how it's done traditionally, which is done in the kernel. So the application we'll be showing today is the packet switching application between two VMs. So there'll be two VMs running on an Ubuntu host, and then the SmartNIC itself runs on a RISC-V QEMU instance, and then that will be responsible for packet switching. Moving on, so the software stack, how does the software stack look like? So let's work from bottom up here. So the bottom platform is a RISC-V QEMU instance, which is the platform here. And everything here has been compiled using GCC as a compiler. The firmware BIOS layer is OpenSBI from upstream RISC-V, and EDK 2.1 Piano Core UEFI as the BIOS. And Ubuntu is a Linux we are using for this demo. On top of Ubuntu is DPDK that runs in user space, and then OVS runs on top of DPDK. And then there's a bunch of VMs constructed using KVM. So these are the VMs that actually do the packet switching, you'll see shortly. And so those are launched using KVM. So this is the software stack that runs on the overall platform itself. A little bit more detail of what we're going to show today. The slide is a busy slide, but I'll kind of try to walk through it. So what we are showing here is a packet switch that happens from the top VM. So the VM that you see on the top right is running on Ubuntu. The bottom is also running on Ubuntu. And what we'll be doing is a switching application where we switch packets from one VM to the other, going through the SmartNIC. So what you see on the left side is the kind of the heart of the whole thing, right? So that's the actual SmartNIC that runs on a QEMU instance running Ubuntu. And that's the one that runs OvS-DPDK. And on the outside stuff, so as packets come in, if you follow the blue arrow here on top, the blue arrow shows the packets that are sent by the VM, and then the red arrow is the ones that are received by the VM, right? This path here. And then the outside world is a loopback. So as packets get out of the SmartNIC, they're pretty much looped back, right? So whatever goes out, you see of the tap 2 interface here, comes back on the tap 1 interface here, and then goes back into the other VM, which is VM2. So effectively, the blue is the incoming packet, and the orange is the outgoing packet, right? And then we have two Wireshark sessions. One is on tap 1, where we monitor the actual outgoing packet. And the other one is the Wireshark on this VM2 Ubuntu, which is the incoming packet, right? So what we'll see is what happens when the packet goes out and what happens when the packet comes in. So let me play this demo here, and this is done by my colleague. So this will be a video that starts playing, and then this will talk about the whole application running.
Hello. The packet switching demo using OvS-DPDK stack will be shown here on my screen. So let me quickly go through the topology of what we have here. On the bottom left, we have the console of the SmartNIC. This SmartNIC is running Ubuntu OS. On the top left, we have the VM running on top of the SmartNIC. On the right hand side, the top right window represents VM1, which will be sending packets using the packet sender application. On the bottom right, we have the VM2, which is capturing the packets which are sent from the VM1 using OvS. And both this VM1 as well as VM2, these are running Ubuntu. In the middle on the top, we have the Wireshark, which will be capturing the packets processed by SmartNIC and sent to the outside world. And the bottom, in the middle, we have the configuration which is required for the SmartNIC. So this demo is divided into two parts. The first part is the plain text demo, and the second part will be showing encryption and decryption using the MAC. In both these parts, the VM1 is sending packets to the SmartNIC. The SmartNIC will process them using OvS-DPDK and MAC, and then the packet will be sent to the outside world, and where we are capturing it on that one. The same packet is routed back to the SmartNIC, where the SmartNIC will process it again and send it back to VM. So in the plain text demo, the packet which is sent from VM1 will be sent in plain text to the VM2, and in the second part, when you access, this message will be encrypted and decrypted by the SmartNIC. So let me quickly send the packet from VM1 to the SmartNIC. If you see here, this private message from VM1, hello world. This we can see here. The SmartNIC has simply switched the packet and sent it to the outside world. And here, if you see on the VM2, the same message is received, hello world. Now I'll quickly change this message to hello Ventana. Here, if you see, we can see the changed message here, hello Ventana, and the same message we can see here on the VM2, hello Ventana. Now, in the second part of the demo, we will be doing the MAC configuration on the SmartNIC. So, let me quickly do the configuration. Now, as you can see, I have done this MAC configuration here on the SmartNIC. So I will be quickly sending this message saying a private message from VM1 hello world to the SmartNIC. So if you see here, the SmartNIC has processed the message. It has encrypted it and sent it to the outside world. Now on the outside world, this message is again looped back to the SmartNIC. The SmartNIC has decrypted the message, and you will see private message from VM1 hello world to this is the decrypted message. Now I am changing this message from hello world to hello Ventana and so on. So if you see, the message is encrypted by the SmartNIC here, and again decrypted and sent to VM1. You can see the change message, private message from VM1 hello Ventana. So this two-part demo concludes this presentation. Thank you very much.
Okay, so as you saw in the demo here, right, so what we are showing here is OvS-DPDK, and the purpose of this demo was to show the maturity of the RISC-V ecosystem, right, that it has OVS, it has DPDK, all the software components available today for deployments to start, right? So this is a networking application. We do have other applications across the board, whether it's networking, storage, security, crypto, web tier, right? Many of those applications are available today. So that's all we have for today. And we have our booth here, the Ventana booth. If you had any more questions, you wanted to understand more about this solution or any of the others that are available in RISC-V today, do come and see us. We'll be happy to talk about it. Thank you.